many of you may not realize that during the Bush administration, back a little ways, Air Force One never landed in Massachusetts with the President and Vice President. Does anybody actually know that? Usually I don't raise your hand about this, but you all know. So, okay, Air Force One doesn't land in Massachusetts, so let's see why is that. That's actually because gay marriage was legalized in Massachusetts, but this is the funny thing about it, the former Commander-in-Chief thought that gay marriage was mandatory. Not just legal, but mandatory in Massachusetts, and he didn't like the twinkle in Cheney's eyes, so they never flew together to Massachusetts. And again, there's this movie based on it. Okay, just a little bit of trivia. You could do what you want with that. Okay, so let's see, near image of Eros. This is kind of cute. This is, I mentioned that Eros is spinning. Well, there's Eros spinning. This is why it's so hard to just come in and land on Eros, because you can't just drop right on this. You actually have to match its spin if you want to come in for some kind of a soft landing. So that's why we had this strange situation of how to take that unusual path to get down to the surface. All right, so now we get to some fun stuff here. We're going to talk about the bulk properties of Eros. This is going to lead to talking about the surface gravity, which is just fascinating because it's so small compared to the surface gravity of the Earth. Okay, well, first of all, we actually had no way to even know what the mass of Eros was until we passed the spacecraft by it. Because remember that you've got to sample the gravitational field of the object somehow to know how strong its gravitational force is, and then you compute its mass from the gravitational force. So again, if we look at Jupiter, we see moons going around Jupiter, so no problem. We've known the mass of Jupiter for many, many decades, or hundreds of years, because you can see moons going around Jupiter, so you know what the force has to be to keep those moons in orbit. In the case of Eros, we saw no moons around Eros, so we had to go there and send a spacecraft to sample the gravitational field. So the estimated mass turns out to be about 7 times 10 to the 18. Now keep in mind the mass of the moon is about 10 to the 25 grams. So we're talking about 10 to the 7 times less mass in this asteroid than the moon. 10 to the 7 times less. So that already gives you a feeling that the lunar surface acceleration is only 1/6 of Earth, right? But this body is only 1/10,000,000th of the mass of the moon, so it's going to have profound consequences for the surface acceleration. The volume turns out to be about 10 to the 18 grams per cubic centimeter. So what we find is that the density is around 2.5 grams per cubic centimeter, indicating a rocky composition, possibly even porous, with some empty channels inside the body. Okay, so again, density of rock is 2 to 4 grams per cubic centimeter. So we think it's probably rocky, probably not too much ice. Now let's compute the surface acceleration. Well, actually, what we're going to do here is compute the surface gravity and the escape velocity. Escape velocity is the velocity that a thrown object would have to have to escape from Eros. Now, there's no atmosphere on Eros, so if you just throw a rock at this speed, it'll escape. But look how ridiculously low that turns out to be, only 15 miles per hour. You could ride your bike off of Eros into space, or you may be able to run so fast on Eros that you actually launch yourself completely off the body. That's how gravitational field is. The escape velocity is that low, only 15 miles per hour, versus thousands of miles per hour for Earth. Now, if we do our usual calculation of the surface acceleration, I won't review the formulas, but the bottom line here is we always calculate the surface acceleration by combining the gravitational constant with the mass of the body and its radius, right? When we do this for Earth, we get 9.8 meters per second squared. When we do it for Eros, we get 1,000th of a meter per second squared. So if I go there with my trusty laser pointer and I let it go, every second after I let go of my laser pointer, instead of 9.8 meters per second, right? It would only, I advanced my car. After I let go of my laser pointer, it's only going to accelerate 1,000th of a meter per second every second. So it's barely going to accelerate. I mean, even slower than what I'm indicating right now, right? Incredibly weak gravity. So this also means that our weight on the surface of Eros would be Well, let's do the math. It's about 9.8 grams per centimeter, or 9.8 meters per second squared on the Earth. This is 1,000th of a meter per second squared. So the ratio there is about a 10,000. So your weight on Eros, if we brought a spring scale with us and measured our weight, it would only be 1/10,000th of our weight on the Earth. Just ridiculously low amount of gravity. But as I mentioned before, there are actually some examples of asteroids that have satellites. Like here we have Dactyl with Ida there. And there are actually many other known examples, which is completely bizarre because with such an incredibly strong gravitational acceleration, how can you get a moon to be in a stable orbit around a body like that? It's just the slightest nudge, and that moon would be gone. So it's really difficult to know how we could actually get a situation like this to occur, where we have a small moon around a very small asteroid, Ida. Ida is actually pretty comparable to Eros, so surface gravity is going to be comparable. So there's a super weak gravitational force holding that little Dactyl in place. How could it be there? You have to kind of surgically put it there in such a gentle way to keep it in that kind of an orbit, because if it flies in with high speed, it's just going to fly by. It's not going to go in orbit. Barely even going to notice that asteroid there. So this may actually be another situation where it was a multi-body process where another body played a role in establishing that orbit. Okay, so acceleration of the surface of Eros is about 10,000 times smaller than at the Earth's surface. This is kind of cute. This is a set of stereoscopic images of Ida. So the way this works is if you cross your eyes and combine these images, you will be treated to a 3D view. Not having to use special goggles, not paying $15. You know, I'm charged to do this. I don't know if you can do it. I can actually do it. I can sort of do it from here, but I usually fall over when I do that, so I don't want to. Yeah, cross your eyes and you combine them. You actually can see that. Wow. Exciting. Okay, sorry, I don't have enough time to really spend much time on that. This is Dactyl. Again, this is the moon of Ida. Even it has been subjected to the indignity of multiple impact craters. And this is a shot, again, of Ida, I think, which again shows us this phenomenon of off-center boulders in the crater. Boulders that are not sitting at the dead center of the crater. Again, because of the weird shape, puts the center of mass at an unusual location in the asteroid. Asteroid impacts have certainly occurred on Earth multiple times. The large river system around Quebec is probably due to an ancient impact. Okay, so this, now we're getting into comments, but I'm slightly over time now, so people will hold off on comments until after Thanksgiving. So just do 2 lectures next week and that'll be it. So have a happy holiday.